Hello students, welcome you all in my YouTube channel Easy Mathematics. I hope you go through the previous all videos where the different tests we have considered. So far we have considered the comparison test, D'Alembert's ratio test, Cauchy root test, then the RAP test. And I told you that the RAP test is the one of the particular form of the Gauss test. So we can say the generalized form of RAP test is the Gauss test. So what is Gauss test? That we are going to discuss in this particular video. So here the given series of positive term is given and we should express un divided by un plus 1. Un divided by un plus 1, that is the nth term and the n plus 1th term in the form of 1 plus alpha by n plus beta n by n to the power p. How we will express in this form, that I will discuss while we do some practical examples. So this one we should express in this form where remember p is greater than 1. P greater than 1 means this part for n to the power p as we consider, this one being a p series with n value greater than 1 is always convergent. 1 by n to the power p, this part is always convergent. Anyways, where this beta n is a convergent sequence, we can express in this way in such a manner so that this beta n is convergent sequence, and obviously 1 upon n to the power p is convergent being a p series with p greater than 1. So if it is happening, then an, that means then the given series is convergent if alpha greater than 1. This alpha value if greater than 1, depending upon that the entire nature of the series will be discussed. That is this series is convergent if alpha is greater than 1 and diverges if alpha less than is equals to 1. Just remember here no test fails. That means in no circumstances the test fails. That's why this one is called the generalized form, and whatever be the nature of the series we can discuss entirely. Anyways, let us discuss this one with an example so that you can understand better. So first of all, the given series is 1 upon 2 plus 1 into 3 by 2 into 4 plus 1 into 3 into 5 by 2 into 4 into 6. That means all the odd terms in the numerator and the even terms in the denominator. So here un is accordingly we should set. So that is un is 1 into 3 into 5, it is up to 2n minus 1, and 2 into 4 into 6 up to 2n in the denominator. Now similarly from here easily we can find out un plus 1 just by replacing n by n plus 1 we can get un plus 1, and depending upon that you can calculate the ratio un plus 1 by un. So that ratio while we calculate its value is 2n plus 1 divided by 2n plus 2. And if we take the limit of this one as n tends to infinity, the limiting value is 1. So hence what we will find out, that the D'Alembert's ratio test, that is the criteria for the D'Alembert's ratio test, and this limiting value 1 means the D'Alembert's ratio test fails. So while D'Alembert's ratio test fails, we should apply the Gauss test. So Gauss test, for what we will do, at first we find out the ratio an by that is un, this is our not a, this is un divided by un plus 1. So that value previously we calculated 2n plus 1 by 2n plus 2, that is un plus 1 by un. Now it is just the reverse. So it is 2n plus 2 divided by 2n plus 1. That we can express as 1 plus 1 upon 2n plus 1. So that if we just now write here in denominator numerator, if we multiply by 2n, then we can write this one, and after that we separate them by 1 plus 1 upon 2 minus of 1 upon 2n divided by 2n plus 1. Just have a look. Here we can simply write down that 2n plus 1 and minus 1. So that this 2n plus 1 with this ratio it will be cancelled, and the remaining part is minus of 1 upon this entire term. So we can write this one as 1 plus 1 by 2n minus of this part. So just look, this one again we can express as 1 plus 1 by 2 as alpha divided by n. Then minus of, here it is, if we multiply n in the denominator and numerator both, then we will find out here n divided by n square. For this 2, we again here multiply with this one so that it becomes 4n plus 2. So now if we compare with this one as the beta n by n to the power p, then we can say beta n should be here minus of n divided by 4n plus 2. So that should be your beta n. So and the 1 by np means 1 by n square we consider as n to the power p, where p is greater than 1. Here it is 2. That's why it is justified. So that we entirely can express this one in this format. So this is the way how to express un by un plus 1 in this format. Whatever be the expression given, just at first we separate 1 by some anyhow. After that the remaining part for we consider in such a manner so that something by n we can take separated and the remaining portion we adjust in such a way so that we can find bn by n to the power of p. So here if we compare, then we will find out alpha is equals to 1 by 2 and beta n is equals to minus of n by 4n plus 2. So when we take the limit, then this limiting value is minus of 1 upon 4. That means when just take n tends to infinity. Therefore, by Gauss test, we say the series is divergent as alpha is less than 1. So that is the nature of the series which we can conclude by using the Gauss test. Now I am going to discuss some important features of this Gauss test. From the beginning I am telling you that Gauss test is the generalization of the Rabb's test. So for the particular case, for some particular situation, we will definitely derive the Rabb test, its situation from this Gauss test. So that we are going to derive now. So if in particular Bn we consider 1, so this Bn, that convergent sequence, if we consider as 1 for all n, then what happens? Then Bn is convergent, that means Bn convergent, when it is 1 then also it is definitely convergent as n tends to infinity, and 1 upon n to the power p is tends to 0 when n tends to infinity. So that the last term Bn by n to the power p, if we just omit, then what happens? So the Gauss test, this expression reduces to un divided by un plus 1 is equals to 1 plus alpha by n. That is nothing but your expression for the alternative Rabb test, if you can remember. If you can't, then you just, I am just referring you the previous video which you go through, where the alternative statement of Rabb test is exactly this one. So that one only we can just express, that means here 1 plus alpha by n is it, for we can take 1 this side so that it is un by un plus 1 minus 1. Then if you multiply this n, then we will finally get this one. So this is the first statement for the Rabb's test. So that one is convergent if alpha is greater than 1. This one is divergent if alpha is less than is equals to 1. So which is your nothing but the Rabb's test. So this is the, from here only we can say the Gauss test is the generalized form of the Rabb's test. Another one form of this Gauss test is there. That form is again very important form for the Gauss test. That is the order notation form. So what is this order notation form? So for that, if un is a series of positive term and if it is possible to express un, okay, it is an I have written here, un by un plus 1 in the form of un divided by un plus 1 is equals to 1 plus alpha by n plus some order of 1 by n to the power p. Some order of 1 by n to the power p, where this alpha is a constant and p greater than 1, then the given series is converges if alpha greater than 1 and diverges if alpha less than is equals to 1. Actually what happened, the Rabb's test for, we entirely omit this last term. But in general, if we take this last one as the order notation form means whatever be the beta n will be there, it doesn't matter. N to the power p, if it is in the power of 2 or more, then we can write it as the form of order of 1 by n to the power p. So if we can write this one, so this entire part is convergent. So if we just verify the nature of the series for this part only, then we have done. That's why this order notation form is important. After calculation of this part, we just omit this part or we just neglect this part and on the basis of this part only we just discuss the nature of the series, divergent or convergent. So the most important practical application of this Gauss test is to find the nature of the series. For that we have two type of series we discussed, that is, one is the hypergeometric series and another one is the binomial series. Actually, hypergeometric series and the binomial series, these two, as an example I am showing you that if these two type of series are there, then we apply the Gauss test, and how on that basis we discuss the nature of these two series. So let us do both the series one by one. First, it is the hypergeometric series. So at first, hypergeometric series, how it looks like. So the series is 1 plus alpha into beta divided by 1 into gamma into x plus alpha into alpha plus 1 into beta plus 1 divided by 1 into 2 into gamma plus 1 into x square, plus here the three terms alpha plus 1, alpha plus 2 into beta plus 1, beta plus 2. Here also 1 into 2 into 3, then gamma plus 1, gamma plus 2, x cube. So this one, if the series is given, then this is the hypergeometric series where this alpha, beta and gamma are real and none of them is 0 or a negative integer. That is, alpha is greater than 0, beta greater than 0, gamma greater than 0, and x is also given as greater than 0. So for this series, if we want to discuss the nature of the series, then at first we should calculate the un, that is the essential thing. So here the un means alpha plus 1, it is up to alpha plus n minus 1 into beta plus 1 up to beta plus n minus 1. Similarly for gamma also, and power of x is n definitely. So from here un plus 1 also you can calculate easily. For un plus 1 it is up to alpha plus n. Here beta for beta plus n, gamma for gamma plus n, and the power is x to the power n plus 1. Now if we take the ratio, then we will find out un by un plus 1 is equals to n plus 1 into gamma plus n divided by alpha plus n into beta plus n into 1 upon x. Just you calculate un and un plus 1 and take the ratio, you will find out this one only. And this one is tending to 1 upon x as n tends to infinity. If we take the limit n tends to infinity, then what happened here? We just divide the entire thing by dividing entirely by n square, so that it becomes 1 plus 1 by n gamma by n plus 1, and here it is alpha by n plus 1 and it is beta by n plus 1. So when we take the n tends to infinity, then the entire thing remaining 1 here, and for 1 by x it will remains as 1 by x. Remember, usually D'Alembert's ratio test we consider for un plus 1 by un this ratio, but here it is reverse. That's why the conclusion also reverse. So by D'Alembert's ratio test, we say the series is convergent when this entire part is our greater than 1. So that means x less than 1 for the series is convergent, and divergent for x greater than 1. So, and definitely the test fails when x is equals to 1. So when x is equals to 1, our un divided by un plus 1 becomes this one just by multiplying these two. If we multiply, we will find out n square plus gamma plus 1 into n plus gamma. And here after multiplying these two, we will find out n square plus alpha plus beta into n plus alpha beta. So now this one we do some adjustment because our requirement is to express the given series in the form of 1 plus alpha by n plus beta n by n square. So now after simplification we will find out it is 1 plus gamma plus 1 minus alpha minus beta by n plus beta n by n square, where this beta n is this one a plus b by n whole divided by 1 plus n alpha by n into 1 plus beta by n. Again where a is equals to gamma minus alpha beta minus of alpha plus beta into gamma plus 1 minus alpha minus beta, and b is equals to minus of alpha beta into gamma plus 1 minus alpha minus beta. If you becomes confused, then just do one thing, substitute this ab here, after this beta n here, and simplify. You will get your initial value, so that you will not be confused that how we will get this one This is actually the back calculation. You otherwise you just go by yourself and very calmly you just simplify. You will find out this expression for this un divided by un plus 1. So that from here we can say that beta n tends to a as n tends to infinity. So hence when x is equals to 1, the series converges if this one is your alpha value actually. So gamma plus 1 minus alpha minus beta greater than 1, that is gamma is greater than, this 1 cancel, so gamma is greater than alpha plus beta, and it is diverges if gamma is less than is equals to alpha plus beta, that is by the Gauss test. Now this is the general form of Gauss test we have applied over here. If the same problem for we apply the Gauss order notation form, we know the Gauss order notation form is un divided by un plus 1 is equals to 1 plus alpha by n plus order of 1 by n to the power p. So that if we if we apply here, then what we will find out from that, for just remember the expression. So that is n plus 1, then gamma plus 1 na? So n plus 1 we can write 1 plus 1 upon n just by dividing the denominator and numerator by n. So it is 1 plus 1 by n. Then next one it is 1 plus gamma by n. And as this 1 plus alpha by n is in the denominator, we take minus 1 as the power if we write in the numerator. Similarly 1 plus beta by n to the power minus 1, that we can write. So after that, if we multiply these two, then we will find out 1 plus gamma plus 1 by n plus some order of 1 by n square, because if we multiply these two, we will find out it is gamma by n square, that we can easily write order of 1 upon n square. Similarly, if we just these are the infinite series, so we just expand this infinite series, so that 1 plus minus of alpha by n plus of alpha square by n square, in this way it will continue. So 1 minus alpha by n plus or some order of 1 by n square, that one. And for this one also the same, 1 plus beta by n plus some order of 1 by n square we will find out. So when we multiply now these two, so that time what we will find out, 1 plus alpha plus beta by n plus, again definitely for the remaining whatever term we will find out, these are the order of some 1 by n square. That means either you will get the term 1 by n square or greater than that. After doing this one, we again multiply these two. So after multiplying these two, we will find out it is 1 plus gamma plus 1 minus alpha minus beta by n plus again the order of 1 by n square. Actually, we are going to neglect the higher order of 1 by n square and above. So finally what we will get from here, that the series converges when this one, that means our alpha is this one, entire alpha is this one. So we will say that when this one is greater than 1, that is gamma is greater than alpha plus beta, the series convergent, and when gamma is less than is equals to alpha plus beta, the series diverges. Now it is the binomial series. We all are familiar with this binomial series. So binomial series is 1 plus nx plus n into n minus 1 by 2 factorial x square plus n into n minus 1 into n minus 2 by 3 factorial x cube, in this way. So that one converges if n greater equals to 0 and diverges if n less than 0 for x is equals to minus 1. When x value is minus 1, this series is diverges if n less than 0 and converges if n greater equals to 0. That we are going to prove by using this Gauss test. So first of all, when x is equals to 1, after a certain stage all the terms have the same sign, and hence we can use the test of positive term series. You may be confused that when x is equals to minus 1, then it is alternatively positive, negative, definitely. But depending upon the n value also, after a certain time, we will get all the terms as the same sign. So here, first of all, un, we can't consider un because n is the nth term is given. N is used in this problem. That's why instead of n, we use r. So ur, we can say the general term, that is the rth term. So then general term is definitely it is n into n minus 1, n minus 2 up to n minus r plus 1 by r factorial into x to the power of r. So from here r plus 1 also we can calculate just by substitute r for r plus 1 here, and you will get easily r plus 1. After getting these two, if we take the ratio, then we will find out it is minus of r plus 1 divided by n minus of r. Okay, so and just remember x value as it is minus 1, that's why it is independent of x. Okay, now this one we should express in the form of 1 plus alpha by r plus beta n or beta r by r square. So that if we want to do so, then this one we can express as 1 plus here from just look 1 plus n plus 1 by r plus beta r divided by r to the power n, we can easily write where this beta r is nothing but n into n plus 1 by 1 minus n by r. You just simply substitute this value here and simplify, you will get this one. Anyways, so this beta r tends to n into n plus 1 as r tends to infinity. Just look, r tends to infinity means this part is 1. So beta r tending to n into n plus 1. So hence, the series converges when alpha is greater than 1. So alpha means here it is n plus 1. So when n plus 1 is greater than 1, so 1 cancels. So that is n greater than 0. So when n greater than 0, the series is convergent, and the series divergent when n is less than 0. So that is just when n plus 1 is less than 0 for series diverges. When n is equals to exactly 0, then what happened? To this binomial, if we substitute n is equals to 0, we will find out all the terms are containing the factor n. So that except the first term, all the terms are 0. So that if we take this summation, then we will find out the value is 1. 1 is a finite value. Hence, we can say the series convergent. So when n is equals to 0, the series convergent. So finally, we can conclude that the binomial series converges if n greater or equals to 0 and diverges if n is less than 0. And that is our proof. So in this way, by using the Gauss test, we can prove nature of the series, and definitely this one we apply while the D'Alembert's ratio test fails, and this one is the generalized form of the Rabb's test. So all these things you should keep in your mind and proceed. You can understand this one, and Gauss test is very important because later on the Kumar's test and the logarithmic test and other tests, while we are going to prove, that time this is the basic. From this Gauss test we can prove all those. So this one is all for this video. I hope you understand. If not, then again I recommend to go through the video once more, because it is little bit difficult to understand. Not difficult, there are so many things are piling together. That's so why, to make the clear conception, go through the video once more, that I recommend. So stay tuned. Have a nice day. Thank you all.